Okay, I'm going to work this problem for you. We have Heppy's buffer. It's 100 millimolar concentration. And that means that's both the weak acid and the conjugate base. If you are given a buffer concentration, it's the sum of both. And Heppy's has a pKa of 7.55. Our first question is, what is the ratio of A minus to HA if we have a pH of 8.1? And so this is going in the opposite direction that you might be used to in terms of the algebra. So I just want to do an example with it. First of all, the pH 8.1 is higher than the pKa of 7.55. That means that there's going to be more A minus than HA. And so we expect this ratio, because A minus is bigger than HA, we expect that ratio to be bigger than 1. We will use Henderson-Hasselbalch equation to solve for this. pH equals pKa plus the log of the concentration of A minus over the concentration of HA. We were given the pH, it was 8.1. pKa is a constant, that's something you would look up in a table. And then we have our unknown. And I'm going to say that this ratio is x, so it's the log of x. If I subtract 7.55 from both sides of the equation, I get 0.55. So 0.55 is equal to the log of x. Now this may be a little unfamiliar, you might not remember how to do this, but if you need to solve for x and it's in a logarithm, if you raise that logarithm to the power of 10, you get what's in it, because they are inverse functions. So 10 to the log of x, when the log is base 10, gives you x. And then we have to do the same to the right side of the equation. And when we do that, x is on the right and 3.5 is on the left. And that is our ratio of A minus to HA. And remember I said in the beginning I expect it to be greater than 1, and it is. It's 3.5. For the second part of this problem, we need to calculate the individual concentrations of A minus and HA. And this is basically a two equation, two unknown problem. So we know that the concentration of A minus plus the concentration of HA is equal to 100 millimolar. We know that from up here. And we know that this ratio is 3.5. So if I multiply both sides by HA, I can get an expression for the concentration of A minus. This side is equal to A minus, and then I have 3.5 HA. So I can take this and substitute it in here because it's the same as A minus. So it would be 3.5 HA plus HA is equal to 100 millimolar. That is 4.5 HA. And then if I divide both sides by 4.5, I get HA is equal to 22 millimolar. And then A minus is going to be 100 millimolar minus 22, which is 78 millimolar.